How's it going, everybody? In this video we're going to take a look at the areas and LSAs of OSPF. And now in the previous video I went over and I did a very basic area 0 peering between router 3 and 5, and I broke down some of the things to look for to make sure that your peerings are coming up and to make sure that the link state database is good to go, and how to verify what's going on and how to read it for the most part. Now, what I thought was going to be very beneficial to everybody was to break down the areas and the LSAs and break down how OSPF works behind the scenes, because anybody can go in there and type in a couple of commands and make the stuff work, but if you don't understand how OSPF path selection works and how the route types and how the scalability factors come into play with the two-level hierarchy, you can quickly find yourself not knowing what to do and scratching your head trying to figure out which way to go. So that's why I figured I would do this, cover this first, then walk into a multi-area implementation and get everything get the two different areas that are sitting next to each other. So area 2, 3, 4, 5 and area 0, get them operational. And then once we have those operational, and we discuss that in some more, we'll talk about some of the things you can do to prevent issues from happening, and then we'll get into expanding it beyond that into the area 123 sitting behind there, where we get into virtual links and talk about how all that type of stuff works. So areas in general add hierarchy and scalability to OSPF. An area defines a flooding domain, so all devices in the area agree on the topology. Changes inside the area require LSA flooding and a full SPF run. So the goal of SPF is to solve the shortest path tree to the node that owns the attributes of a prefix. That's the idea of OSPF. Solve the shortest path tree to a router LSA, and you at the same time solve the shortest path tree to the prefix. So if router 1 is advertising a route and you solve the shortest path tree to his router ID, you not only solve the shortest path tree to him, but also all of the networks that he's advertising. Because OSPF does not solve the shortest path tree to the prefix itself, but to the router that's advertising those out to you. So when it comes to routing between areas, you get into some issues, and the general idea is when you're doing inter-area routing, it's similar to distance vector. So in area 0, to route to a prefix in area 1, you have to solve the shortest path tree to the ABR that's being advertised to that area. Now, once at the ABR, solve the shortest path tree to the node that owns the attributes of the destination prefix. Changes outside the area don't always require an LSA flooding, but when you're dealing with... So when we talk about how routing between areas is actually like distance vector, what you're going to do is you're going to route any of your internal traffic to an ABR, and once you hit that ABR, you can't see beyond that. You see what the network, the summary link state is telling you with the type 3 LSA, but beyond that you don't know what's being advertised. So you recurse to the ABR, and then from there on you don't care. Same thing with EIGRP and RIP. You don't know what's being advertised to you from beyond your next hop. So with EIGRP and RIP, you learn whatever routes that the next hop knows, and you're hoping that they're right. And most of the time they are, but you don't always know that they are. So that's why routing to inter-area routes is similar to distance vector in the same regard. So a two-level hierarchy. Now, from coming back from your CCNA days, you probably heard about a backbone area, and you probably heard about a non-backbone area. So area 0 is the backbone area. It's used to summarize topology info between other areas. This is not summarizing NLRI, it's topology summarization. So type 3 LSA, ABR, is a network summary, and then you have the LSA type 4, which is the ASBR network summary. This is not area range, which is area summarization, or NLRI summarization. So the area range allows you to filter basically on a particular prefix or a range of addresses, where when you're dealing with topology summarization, you're dealing with the routes that are the rest of the network that's being advertised to you from the ABR. So traffic from one area to another must go through area 0. It must be contiguous. So area 0, for the terms of backbone, needs to be there. Now, if you have a situation where it is not the backbone, let's say area 0 is not even employed, you will not be able to route between your areas because of the fact that you don't have an ABR. And in order for an ABR to form, you need to have at least one area on a router in area 0 for it to be an ABR. And we'll talk about that more in detail later on when we get into virtual links and how to bridge that. But if you don't have at least one interface in area 0, you're just another router. Now, non-backbone areas are all other areas 1 through all 255s. So you can actually type in your information in as a dotted decimal, like you see there. I've got the one highlighted. Or you can just type in area 0. You can type in area 0.0.0.0 is the same thing as typing in area 0. So now that we talked about that, let's talk about the router types. And this, I think, will start to help everybody get clued in here. Router types are going to be backbone, at least one link in area 0. Now, if you have all links are in area 0, that's what they call a backbone router. So one and the same is the backbone. Any router that's in area 0, regardless of how many interfaces there is, it's a backbone router at the end of the day. If you have an internal router, you have all links in a non-backbone area. If you have one link in area 0 and one link in a non-backbone area, you have an area border router. If you have a router with a link in area 0, a link in a non-backbone area, and another link in a non-OSPF domain, say like the internet or EIGRP or BGP, that is what we like to call an autonomous system boundary router. And what that guy does is and technically doesn't have to have a link in another area. I was just saying that's a possibility. So if you have a router with at least one link in the OSPF backbone and one outside the OSPF backbone, then that is an ASBR. Now, it says one link in the OSPF domain, and that technically is true. It doesn't have to be area 0. These are all variations of how it can work out. So let me just break this down. If you have a router with a link in area 0 and in a domain outside of OSPF, ASBR. If you have a router that's got a connection to a non-backbone area and outside OSPF, ASBR. If you have a router that's got an attachment to area 0, a connection to a non-backbone area, in addition to connecting off to a non-OSPF domain, it is an ASBR. So it really doesn't make a difference how you carve it up. At the end of the day, it's the same thing. What makes an ASBR is the redistribution of information into OSPF. That's what makes a router an ASBR. The moment you introduce the redistribute command, you automatically are making that an ASBR. So we'll talk about that more in detail. And the ASBR is going to advertise a Type 4 LSA. And the Type 4 LSA is going to be the external routes. And it's also going to advertise a Type 5 LSA. Type 5 is an external LSA. So the LSA types are going to be pretty straightforward for the most part. So types are sent and received depend on the router type, the network type, and the area type. So let me talk about the LSAs real quick, and then we'll get into some of the other details. So we have the router type, network type, and area type. We have Type 1 is the router LSA. This is going to be whatever the router has directly connected to it, and its transit route to get to another OSPF router. That is a Type 1 LSA. Then if you were to break that down just a step farther, you would have stub and transit. So when we get into Type 2 LSAs, are only seen in a broadcast and a non-broadcast multi-access environment. So if you type in IP OSPF network type broadcast or MBMA, then you're going to have a DR LSA advertised, which is going to be the network link state. The Type 3 ABR, or Type 3 LSA is the ABR LSA, which is advertised as the summary link state, which is advertised by ABRs into each area. So if you have a ABR sitting at Area 0 and Area 1, the ABR is going to take Area 0 routes and advertise them to Area 1 as inter-area routes, and same and vice versa. It's going to take type Area 1 routes and advertise them as inter-area routes to Area 0. What you're going to do when you were if you were to look at that, you would recurse to your Type 3 LSA to reach the Type 1 LSAs that are being advertised by the internal router in the other area. So you recurse from highest to lowest. You go Type 3 to Type 1 because you're trying to reach the router LSA that's being advertised by the node in the graph. Type 4 LSAs are ASBR. Type 4 LSAs are going to indicate to you that a route has been redistributed in, and you need to recurse to that. If you are Type 4 is in inter-area external destinations, which means that if you're trying to reach something that's outside of your area, and it's external to you, so it's not an OSPF route that's being redistributed to you, and you have to use another what's the word I'm looking for? If you have to leave your area to get to somebody else, then that's a Type 4 LSA. A Type 3 LSA is going to be you're leaving your area to get to somebody else. It's a Type 3 LSA, but it's an internal OSPF route. That's the difference between them. Now, Type 5 LSAs are going to be external routes. External routes are going to be anything that's redistributed in that's clearly anything outside of the ordinary, or outside of OSPF, and then those guys are going to be redistributed in as a Type 5 LSA. You see a Type 5 LSA, you know that's the actual external destination. And Type 7 LSAs, and the reason why we're skipping over Type 6 is Type 6 is the multicast OSPF, and Cisco iOS does not support it. So there's actually a command you can use. It's no LSA Type 6 MOSPF is basically what it looks like, or no Type 6 LSA. It's going to drop it if it receives it. Then we have Type 7 NSSA, or not so stubby area. Not so stubby area means that you are a non-backbone area. You're not accepting in Type 5 external LSAs, but you're still going to allow redistribution into your area, which means you're going to be able to redistribute either a route into OSPF or vice versa, and you are going to be receiving redistribution in, but instead of advertising that as a Type 5 LSA, you're going to advertise it as a Type 7, because Type 5 LSAs are not allowed in stubs, regardless of what type they are. Once you have that Type 7 LSA in there, you advertise that to the ASBR, and at this point in time, the ASBR is going to receive that route and has a choice. It can either translate that from Type 7 to Type 5 to advertise it into the backbone area for it to advertise routes out, or you can simply turn that translation off and not let it do that, to where the Type 7 LSA will be inside the NSSA only area. And we're going to talk about this more in detail later, but it's important to understand how this stuff works. So there's with the three groups with the LSA and route types, we have the three groups. We have intra-area is Type 1 and 2. Routes is O routes. Inter-area routes are OIA, which is Type 3 and Type 4. And then we have external routes, Type 5 and Type 7. So N1 and 2, NSSA 1 and NSSA 2. So we're going to get into NSSAs later on, but the general idea is pretty straightforward for the most part. So if you need to get to something inside your area, you're going to choose a Type 1, or I'm sorry, you're going to choose a intra-area route over an inter-area route. So it goes intra-area, inter-area, E1, N1, E2, N2. And that's the hierarchy going from top to bottom, from highest to preferred, because you're going to route to something that's inside your area before you're going to leave your area to reach something. So if you're going to try to reach somebody that's outside your area, and you have a better path somewhere else, some other direction or some other way, and it's through an intra-area, you're going to choose the intra-area route because of the fact that it's inside your area. Now, there's some corner case scenarios, and I don't know how far we're going to get with that in this series, but we'll take a look at some of the different ways you can use that. So, when you get into Type 3 and Type 4, you're leaving your area. Either you're leaving your area to go to an external route, which is a Type 4 LSA, or you're leaving your area to go to some other OSPF route that's advertised from another area. So that's the general idea of how that breaks down. Now, Type 1, we'll talk about the different LSA types for just a moment, and we'll get into it how we go along. So the router LSA is generated by every router in the OSPF domain, and they are not flooded outside the area they are originated in. They have area local scope. So it describes directly connected links. What are my link costs and who are my neighbors? So it's going to advertise his directly connected routes, so his stub networks, and also his transit routes. So we're going to take a look at this more when we actually get into it, but you'll see the LSA database grow pretty quickly if you start doing multi-area, but it gives you more scalability when we break it down. I'll show you guys how that works coming up. So now Type 2 LSAs are going to be your DR. This is going to be the network LSA. So the network LSA is going to be generated by the DR on a broadcast, non-broadcast network type. It is not flooded outside the area they are originated in. It describes who is adjacent with the DR. So what you're going to do is the DR acts as what they refer to as a pseudo node. The pseudo node is going to be similar to what DIS or the dedicated intermediate system in ISIS. But basically, what the idea of the DR BDR is, when you have a broadcast segment, you're going to want to do a full mesh of peerings, but you're going to use it in more of a BGP route reflector type of situation, where what you're going to do is you're going to have a group of routers. We'll say you have 4 routers. What you're going to do is, we'll say router 1, 2, 3, 4. We have router 1 and router 2 become the DR and the BDR. What's going to end up happening is router 1 and 2 are going to form full peerings with 2, 3, and 4. So what's going to end up happening at that point is router 1 is the DR, router 2 is the BDR. Router 3 and 4 are DR others. Router 3 and 4 are going to form a two-way peering with each other, up to exchanging hellos and seeing each other's router IDs. That's as far as it's going to go. It's going to go to two-way. Routers 1, 2, 3, and 4 are going to go full adjacency, because 3 and 4 are going to peer with router 1 and 2. Router 1 is going to receive a bunch of updates from router 3 and 4 and 2, and he's going to unicast update his the LSA databases down to all of the client routers. So all the routers that aren't DR. The DR is there to be the central point of attachment, if you will, and the DR is going to be the way that the DR works essentially is, if you can recurse to the DR, you have at the exact same point in time found your you've also recursed to other routers inside that area or inside that broadcast segment. So the idea behind it is, so this is the DR is the central point of management. If you can reach the DR is able to reach all the routers on the segment. This means if you can reach the DR, you should have reachability to all the routers on the segment. Now, pretty straightforward for the most part, but it's important to break that down, understand how that works. And we'll talk about that more in detail later on. We'll actually talk about manipulation and stuff like that. And then we have the Type 3 Network Summary LSA, or the Summary LSA. Not to be confused with the Network Summary LSA. Or the network, actually, let me pull that out of there, because this is probably going to mess people up. Let me do this. Now, this is going to be the Summary LSA, because it's actually going to show up as a summary. The Summary LSA is the ABR. It's generated by the ABR and flooded from Area 0 into non-backbone areas and vice versa. So they learn everything. What the ABR is going to do is it's going to advertise any routes that come from Area 0 as an inter-area route into the non-backbone area. Any routes from the non-backbone area that hit the ABR are going to be advertised into Area 0 as a Type 3 LSA. So if you want to get from Area 0 to Area 1, you recurse to your Type 3 LSA, which is going to be the ABR. Once you've hit the ABR is going to look at it and say, okay, who advertised me this route? He's going to look at the advertising router and say, okay, well, there you go. We're going to advertise to him. That's how we're going to get to where we need to go. So the idea behind that's a general idea of how that works. I mean, there's not a whole bunch beyond that to really just break it down. But so now when it comes to it says SPF not run for ABR advertised routes, and the reason for this is because the ABR can reach links in link A via SPT cost and X. So the idea is, if you are trying to recurse to the ABR with a particular cost, so the idea is I can reach the ABR via, or the ABR could reach link A via SPT and cost X. I can reach ABR. So this is the ABR being able to reach the destination. This is you being able to reach the ABR in a particular cost. So you take X and Y, you add them together. This means that if you can solve the shortest path tree to the ABR solves the SPT to the destination, then you can reach the destination. So the idea is you solve your shortest path to the ABR. That's all you worry about in your area. Once it hits the ABR, it's the ABR's responsibility to reach the next hop. ASBRs do a very, very similar thing, generated by the ASBR. And the ASBR can also be an ABR. So it can be advertising a Type 3 LSA as well as a Type 4 LSA. Now, depending on where you're trying to recurse to, will determine which type of LSA you recurse to. If you're trying to reach an external LSA, you're going to use the Type 4 LSA. If you're trying to reach something that's outside your area but internal to OSPF, you're going to use a Type 3 LSA. Flooded from Area 0 into all non-backbone areas and vice versa describes ASBR's reachability to ASBRs in other areas. Includes cost but hides the actual path to destination. So the idea is, if I can reach the ASBR via and cost of X, if ABR can reach the ASBR and a cost of X, I can reach the ABR and a cost of Y. This implies if I add X and Y together, I can find my destination. So you recurse to the ASBR, or the ABR in this case, which is the same box, or could be the same box. Normally is. Once you recurse to the ABR, you solve SPT to the edge of your area, then you use the Type 3 or Type 4 LSA to recurse to wherever you're trying to get to from that point. So we talk about how Type 5 LSAs. Type 5 LSAs are generated by ASBRs and flooded into all non-stub areas. You cannot learn a Type 5 LSA in a stub area or a not so stubby area. They are rejected. So when you're dealing with that, the general idea is you're redistributing something in. So you have the metric and the metric type. The metric type, which is going to be Type 1 or Type 2, and the idea behind it is the metric on any redistributed route is going to be a metric of 20. What you're going to do is you're going to take a look at the Type 1 and Type 2. Type 1 means that whatever the cost is to get advertised from the ASBR to into OSPF, in addition to all the other hops to get to a particular destination, that is going to be added together, and then that's going to be the total cost. Type 2 means whatever the metric is when the route is redistributed, that is the only metric that is ever looked at. It doesn't matter how many routers it traverses, the metric is going to stay the same as to what it was when it was advertised. So the forward address. So who should I route towards to reach the link? Usually ASBR itself, but could be someone else in some designs. So advertise the route to you, but tell you to use another router to reach the destination. I send you the route, but tell you to use another next hop. We're going to talk about the forward address when we get into it, but the forward address, if it is an all zeros forward address, that means it's an external OSPF route, which means you're going to recurse to the advertising router address, and you have to have a route to that address. If it is a ASBR, if it's a forward address with a non-zero value, you're going to recurse to that address, whatever the forward address is. You can actually turn the forwarding address off, do a forward address suppression, and then it's going to force it to recurse to the ASBR or whatever the forward address is only used in external routes because of the fact that you're going to be trying to reach something external to your network, and we'll take a look at how that would work as we go along. And then we have type 1 and type 2 external routes. And let me just break this down a little bit more to you. It gets more interesting as we go along. And that's why I decided to take the time to show you guys this now before we got into it, because it's going to get more and more complicated to break things down. And I'm going to rehash this over and over and over again. I'm going to be constantly showing you how to recurse and break things down. So the external type 1 and type 2 is pretty straightforward. So again, external route type controls how metric for external link is calculated. So type 1, take the cost of the ASBR reports in plus the cost to the ASBR. So what you're going to do is you're going to take whatever the cost of the redistribution plus whatever your cost is to reach the ASBR. You're going to take these two costs and you're going to add them together. That becomes your metric. Depending on how far away you are from the ASBR, your cost might be higher or lower depending where you're at. With type 2, you take just the cost the ASBR reports. If there is a tie, you take the cost to the ASBR as well. So it gets a little hinky when you get into that. So I have cold potato and hot potato. Hot potato routing means find the closest and fastest point off the network and ship the packet that way. Cold potato routing means you find the most optimal internal route through your network and make the forwarding decision that way. So we'll take a look at this in detail as we go along, and take a look at the external route calculation. I think that will that'll help a lot of people out. So as we start discussing external route calculation, there's a couple of different terms, or I like to I don't exactly know the best way to refer to them, but I'll just say the way that they're going to be routed, for the lack of a better term. So remember, external routing, so when you hit an ABR or an ASBR, once you hit that type of routing, so inter-area routing is going to be like distance vector. So the concept I want to bring up to you is the concept of intra-area external versus inter-area external. So an intra-area external means that the ABR can reach the link in a cost of X, and I can reach the ASBR via the shortest path tree and cost of Y. I can reach link A via the shortest path tree and cost X plus Y. So the idea here is when you're dealing with an intra-area external, that's an external route to an ASBR that you're in the same area as. So if you're in area 0 and an ASBR is in the same area as you are, you're going to use that guy to get out of the network, and that is going to be how you route your traffic towards him. So it's going to be intra-area. Now, there's another concept known as inter-area external, which is just adding one more step in the recursion process. The ASBR can reach link A at a cost of X, and the ABR can reach the ASBR via the shortest path tree and a cost of Y. I can reach the ABR via the shortest path tree and a cost of Z. So I can reach link A via the shortest path tree and a cost of X plus Y plus Z. The idea is you do a recursion from, it actually breaks it down. Recursion works like this. So a type 5 LSA external is advertised to a node in the graph. So if a source wants to reach the external destination, it has to route to the ABR. So you route from yourself to the ABR. So type 3 LSA. So you work your way up. So then once you reach the ABR, now you have to have a route to the ASBR. So you go from type 3 to type 4. Once you hit the ASBR, then you route to the ASBR, and then once you hit the ASBR, you recurse to the external, which is the type 5. So technically this one here is wrong because you're not going to have a type. That's actually incorrect. It's going to be type from type 3 because you're going to have to go to the ABR. Then it's going to be type 4 to reach the ASBR. Then type 5 to reach the the external route. So again, if you understand the concepts of route recursion and what the different border routers and different LSA types mean, then you can start to build learn and build the shortest path tree out of the shortest path out of the link state database, and it becomes relatively straightforward for the most part. It just takes time to grasp the concepts. So now that I've laid all that foundation down, we're going to go into the next video with a multi-area implementation. I'm going to show you guys how to do the recursion, and then what we're going to do is we're going to take a look at setting up virtual links for a non-directly connected backbone, and we'll talk about how that works. And then we'll actually, let me bring up our diagram real quick. My intention here is, we're running area 0 here. Let me grab red. So red, we're running area 0 right here, right? That's where area 0 is running. Actually, that's a really, really ugly looking circle. So area 0 is running right here. Now in blue, I'm going to make this area 2345. So this is area 2345. So this means that router 3 and router 5 are going to be ABRs. Same thing with this guy, ABR. My intention, and we'll go to green here, we're going to run area 123 here. So then this guy right here, router 2 and router 4 will be ABRs. Right? And then this one over here is going to be an ABR. So that's how we'll get that going. Now, and this is assuming that this is not doing any external routing into the domain. The moment, and I'm going to go to brown. The moment I redistribute a route into OSPF, whether this is a stub area, whether it's a not so stubby area, whether it's just a regular area that we use a virtual link to bridge area 0 over the non-backbone area 2. The moment you advertise or redistribute a route into OSPF, this router right here becomes an ASBR. So this guy becomes an ASBR. So is this guy. They're ASBR. Right? But at the same point in time, they're also an area border router because they're sitting on the border of two different areas. Now, this guy right here, 3 and 5, are still just regular areas until we redistribute something in this way. Then they both become ASBRs because they're external to the domain. Now, if I wanted to reach from router anything in area 0, so if I advertise the loopback into area 0, I'm going to use a type 1 LSA to reach that in area 0. Now, if I take a route and I advertise a loopback into OSPF into area 2345, actually, let me go back to blue here. If I advertise a route into area 2345 and I learn it via area 0, even though I'm physically connected to it, but I learn it in area 0 as a external route, or I'm sorry, as an inter-area route, I have to first recurse to type 3 LSA, go to the ABR, and then I have to recurse to type 1 LSA once I get to that area. Now, let's assume for a minute here that, and that's what what I like to refer to as an inter-area lookup. Now, let's say, for instance, we advertise a route in from here. Let's say we redistribute BGP into OSPF, and what ends up happening then is in area 0, the external route will be an intra-area external. So it's going to be a type 5 LSA lookup. It's going to be an intra-area external because he doesn't have to leave his area to reach the external route. Now, with router 3 advertises that route into area 2345 via a type 3 LSA, and router 2 learns that route. Now that becomes an inter-area external because router 2 has to recurse to the ABR, which is router 3, so he has to recurse to type 3 and then recurse to type 5 to reach it. So now that's assuming that. Now the part that becomes complicated is when you're dealing with ASBRs. Now this guy is also an ASBR. Now the inter-area external is going to be any route that you're trying to get to that's outside of the domain. So what ends up happening now is you recurse to router 1 would recurse to router 2 because it's a ABR. So we're building the tree back up. So we have This guy is technically an ASBR as well, so ASBR. So we're just going to use router 3 for the time being. So what we're going to do now is router 3 is redistributing a route into OSPF. Area 0, area 2, 3, 4, 5, and now area 123 are all learning it. So now, if router 1 wants to reach the external of 8.0, or I'm sorry, 8/8, he learns that route in. Router 1 learns it via router 2, so he does a type 3 LSA lookup. Looks for the ABR. He looks for the summary link state. Says go to router 2. So he advertises to router 2. He hits router 2 and says, okay, I'm trying to get to this subnet. He looks in at the routing table. The link state database sees it as a type 4 LSA. So he says, I need to get to the ASBR summary because it's an external route. So there he does an inter-area lookup. He goes type 4 LSA lookup, gets to router 3, and then this guy, when he gets here, it's a type 5 external, so he does that lookup, and then he finds it as a type 5, and then he's able to exit the network. So we go 3, 4, and 5. If you're in here, it's going to be 3 to 5. So as we go along, I'll break this stuff down to explain how we're going to get to where we need to go and all that type of stuff. But it's relatively straightforward for the most part. I keep saying that, but if you haven't spent the time on it to really learn how this stuff works, I say it's relatively straightforward, but it can be very confusing if you don't understand the recursion process. And if you are going to attempt to get into CCNP and you want to get the certification and you want to eventually move into CCIE like I have, I'm not a CCIE, but I'm about to take the lab. If you've gotten to that point, this should be relatively second nature to you. If it's not, you need to spend more time on it. And we're going to spend a significant amount of time on BGP as well, because it's when I took the exam, I didn't get nailed with a lot of BGP, but it was still enough. I still had to know at least a decent amount to really understand how it worked. So that's what I wanted to try to relay to all of you, and then draw it out so that it would make more sense. So if I confused you with that diagram, I apologize, but basically both ways are going to be doing both traffic forwarding based off of the type of LSAs that it learns. So make sure you understand what an LSA is, and you should be pretty good to go. So I hope this has been informative for you, and I'd like to thank you for viewing.